those tectonic plates have these boundary lines where they meet. And along those boundary lines, where those tectonic plates meet, they fit together like puzzle pieces, and they're constantly moving and bumping into each other and grinding and building up pressure. Now you can see here we have the outer layer. The outer layer of the Earth, called the crust, that sits on the mantle. The mantle is liquid rock. It's molten hot liquid rock. And the crust sits on top of that liquid rock and shifts around depending on the movement of the mantle underneath. Now when we get to those places where those plates are coming together are our plate boundaries. And we have three major types of plate boundaries. And in order to demonstrate this, I want everybody to put your hands up. There you go. Get your hands up. Yeah, you in the back. Your hands up. Yeah, okay. There you are. And these are going to be your tectonic plates. Now, in this first divergent plate boundary is when the tectonic plates are dividing, are separating from each other. Divergent means to divide, so they're moving apart from each other. And then that fresh molten magma from the mantle comes up and hardens and forms new rock. Then here we have convergent. Converge meaning to come together. So that's when we have two plate boundaries where the plates are coming together. And when they do, they can cause lots of different things to happen. We'll get into that in just a moment. And then finally, we have our transform plate boundaries, or transform fault. And that's when you have two plates side to side, and they're sliding along each other and grinding each other as they go. So earthquakes are caused when these two tectonic plates are rubbing together or bumping into each other, and they build up pressure over time. And then suddenly that pressure pops and releases, and we have an earthquake. So here you can see we've got the Indian plate right here where the country of India, your country, sits right on top of. And that plate boundary is right along this line. Right along this line right here. And you can see it's pushing up into the European plate. And this picture over here demonstrates all those little dots are indicating earthquakes. Those are earthquakes that have occurred, and you notice all the earthquakes that are happening are right along that plate boundary. Here in the middle of the country, not a lot of earthquakes. But along the boundary, that's where all the earthquakes occur, because that's where the Indian plate is being pushed and shoved into the Euro-Asian plate. So it's time for the question, kids. Does the movement of the tectonic plates only cause earthquakes? What do you think? We're going to take a poll right now, and I want you to find out in your class. I want you to raise your hand if you think yes, put your hand down if you think no, and we're going to see, I want your class to ring in if you think it is A, yes, or B, no. We're going to give you 30 seconds. All right, what classroom? All right, classroom TCV 5. Oh. All right, classroom TCV 5B. I see that we have a student that wants to share our answer. Can you please step to the microphone and tell us what's on your mind?
Answer is no, because it can cause other than earthquakes, like volcanoes.
All right, I heard an answer of no. Let's see if my marker's going to work here, and it won't. But you're absolutely correct. No, it does not just cause earthquakes. It causes other things, and we're going to talk about that, a few of those right now. It also causes volcanoes. This destruction of the movement of the living earth also causes these volcanoes. And here we see the Barren Island volcano that is the only active volcano in India, and that is located southeast of India, and an island in the Andaman Sea. And so that is the only active volcano, and that is also caused, most volcanoes occur close to a tectonic plate boundary. Just like here we have in this video recently, the Iceland volcano eruption.
In Iceland, fifth largest glacier. So far, there's no threat of glacier ice melting that could trigger widespread flooding, and no reported injuries.
Now, that Iceland volcano was absolutely enormous, largest volcanic eruption that we've had in many, many years. And that is reminiscent of the Mount St. Helens volcanic eruption that occurred in 1980. And then Mount St. Helens is located in the northwestern United States. And that eruption was so great, it kicked up so much dust and ash into the air that the global temperatures dropped for 2 years by an average of about 2 degrees. So volcanoes can have a tremendous effect on our climate. Now, if we look at this diagram, we see most volcanoes form along tectonic plate boundaries. Now, this is a divergent plate, and convergent plate. We have one plate going underneath another and melting back into the earth. And where that occurs, right here, we have all this lava coming up to the surface and creating our volcanoes. Getting back to your question, students, why do volcanoes occur? And that is a fantastic question. And so this little video is going to demonstrate and show you just exactly what I just explained.
So we want to make sure that it gets a little bit thinner.
A few hundred years ago, scientists believed that volcanoes were burning mountains of fire. Today, we know they're really openings or vents to the hot interior of the planet. About 1,500 volcanoes around the world are classified as active. Nearly 90% of these rest in the Ring of Fire, a band circling the Pacific Ocean. Their location is no accident. While the Earth's surface looks stable, its crust is made up of immense slabs of rock, like puzzle pieces that constantly shift. Where these tectonic plates interact, volcanoes often form. Friction from shifting plates melts the Earth's crust, causing rock beneath the crust to liquefy. This molten rock, or magma, then becomes a volcano by erupting through rifts in the plates. Once magma escapes from the Earth, it's called lava. But not all lava is the same. Runny lava flows quickly and forms the gentle slopes of shield volcanoes. Thick, sticky lava doesn't flow as far and tends to form the steeper slopes of composite volcanoes.
So that video demonstrates a little bit of how volcanoes actually occur along those plate boundaries. Now, getting back to our vocabulary terms, a couple of terms you heard. First was lava. And lava is nothing more than melted rock coming from the inside of the Earth. Once it surfaces and is out in the open,